Hello, everyone. This is Lorenzo Batista, and thank you for coming to today's webinar for Safety in 20 Indoor Air Quality today. I please ask everybody to hold your questions until the end, or you can reach me at my email, which is going to be Lorenzo or lbatista@energyharness.com. My information will be shared here at the end, and I hope you enjoyed the information. It's very informational. So a little bit about Energy Harness and us, what we do, how we got here today. We were established in 2010, and we specialized in the manufacturing and nationwide distribution of high quality commercial LED lighting products. Now that brought us to where we are today, because in 2020, obviously we we all hit a wall, I guess we could say, with COVID, with widespread viruses. So we really began researching and taking our experience from the lighting industry, and we researched into our UVC air purification device, which includes the use of LEDs. And so our goal was to create a patented solution to combat COVID. Now, obviously, why is this important today? Why do we need better indoor air quality? Well, this was an interesting quote I found from the EPA. Americans on average spend approximately 90% of their time indoors, one, where the concentrations of some pollutants are 2 to 5 times higher than typical outdoor concentrations. That means that we are spending all of our time in areas where we really can't control what our quality of air, what we're breathing in is like, and we should be able to do that. Now, I've kind of broken up two separate sections. There's avoidable factors that we see on a daily basis, and then there's non-avoidable factors that we see. So the avoidable factors, these are things like pesticides, personal care products, routine household cleaners, ozone from air cleaners that you may be using, and paints. All these things you can control. You can control the pesticides that you're using around your home, who's spraying, what they're using. You can obviously control what kind of products you're using in your own home. And of course, paints that you choose to paint your business or your house with. These can be chosen, these can be avoided. However, there's a list of non-avoidable factors, and that's something that's really important that we should be aware of. Pollutants, pollens from everyday outdoor dust and mold coming in. I know in Florida, we see mold all the time because of the large humidity levels that we have. And so it's very important for us to combat that and think smart when planning for that in our buildings. And then obviously the building materials themselves, as we have progressed in time, different building materials have been used, and we've seen quite a drop in actually the quality of the materials. Some of them are worse for you than others, so it's important to know if you can, but it's not always avoidable. And then of course, viruses and pathogens. So of course, I said viruses and pathogens. This whole indoor air has really been accelerated by COVID-19. And we say this because we know the usual, wash your hands, wear a mask, self-distance, but it's really important to know how COVID-19, all the COVIDs that are coming out are transmitting. And this is really through air more so than on surfaces. So our indoor air cannot be cleaned with masks. It can't be cleaned with vaccines. It's really important to have a preventative measure and preventative steps in your building in order to protect yourselves, as well as your customers, your employees, and to keep business going. So the question is then, what are the guidelines for indoor air quality? Well, some of the guidelines you can see and you can look up yourself, which I'll have attached here at the end. The American Society of Heating, Refrigerating, and Air Conditioning, or ASHRA, recently released a public indoor air quality design guide for new building construction. And inside that, you actually find a section that specifically relates to ultraviolet germicidal irradiation. This is new. This hasn't really been considered before, but since we are seeing spiked elevations in viruses and pathogens, and this is really a new concern that we all share, it's very important, and it has its own section in this quality design guide. Now, there are also other standards which include OSHA's standards, which are ventilation for acceptable indoor air quality, thermal and environmental conditions for human occupancy, and then obviously a standard guide of cleaning commercial buildings and institutes. So if you want to take a look at those are going to be linked here. Please feel free to take a look at them. They are very important, but we all come to a similar conclusion, which is a key component of our indoor air quality relies on ventilation. So there are several options that improve indoor air quality via ventilation. We're going to talk about those today, and we're going to talk about their strengths and weaknesses and what we recommend through the research that we've done here. The first of that being HVAC. So HVAC systems, you're probably most familiar with this one. Everyone has an HVAC system. Everyone has filters. You probably have been told about HEPA filters since the recent spread of coronavirus, and then UVC devices inside HVAC systems. So a HEPA filter, this is something that is important, is a very high rated filter. It's actually not recommended for a lot of general AC units. If you have an AC unit that can handle it, that's great. However, most of us do not. And so it's actually recommended for you to use a MERV filter, which is more common in HVAC systems, and it does filter out 0.3 microns as opposed to the 0.1 microns for a HEPA filter. And now the reason you want to use a MERV and not a HEPA filter is that HEPA filters put a lot of strain on your HVAC system. So your filter, the smaller it is, the harder the air has to be pushed to move the air through that filter. That can cause issues later on for your HVAC system. That could cause issues for your actual AC. It's just not intended for businesses and homes. So I recommend a MERV filter if you're looking into that for a one solution. There are also UVC solutions for HVAC systems. However, it's important to note there are a few things that make UVC work and effective, and it simply cannot be done in an HVAC system. So what is typically done when you're using UVC in an HVAC system is you put a pre-existing, or you're using a pre-existing HVAC system with a new UV light in it. Now, this is set to the optimal wavelength of 265 to 275 nanometers, which is optimal for germicidal irradiation, meaning kills germs. However, the problem is we see that HVAC systems are designed to push air. So they push air very rapidly. They have to accommodate for tons and tons of air. That is their sole purpose. Now, for UVC to be effective, actually the air has to be moving fairly slow. It needs to be exposed to the UVC, and it needs to be relatively close to the source. If you see this picture above here, that's actually just a light in a large area where air is moving very quickly. That's pointed at the filters. So the goal is really not to clean all the air. It's really to clean the filters. So if you're looking for a solution that's going to clean your air, this isn't going to do everything that you thought it may. So it's very important to realize that. So it's really acting as a surface disinfectant for those filters, not an air purification. Important to know. So next on the list is ion generators or ozone generators. Now, these are charged particles that grab on or attach to walls, surfaces, floors after attaching onto a particle. Now, they usually remove or attach to small particles like smoke, but they cannot remove gases, odors, dust, pollen, and other larger particles. It's too heavy for them to attach onto. Now, these actually are made naturally from waterfalls, and that's one way that ions can be made, negative and positive ions. However, they only last for maybe a few seconds in nature, and when they are created artificially with these generators, they only last for split seconds. So how effective are we actually doing in cleaning the air if we can only produce something that's going to last for a few seconds? Not very effective. The other big concern about this is you see that it says ozone. It creates ozone indirectly. This is worse than normal ozone. It's basically considered smog. It's a lung irritant, and it's significantly higher levels considered harmful for humans. So this is a big problem, and I've seen a lot of this happening before where people can smell the actual ozone being created by these devices, and it's not healthy for you, especially if someone has any kind of lung problems. So the CDC and the EPA do not suggest this method, and neither do we. It is not recommended for a air purification device. Next up is the positive and negative pressure systems. So these are great systems. They are typically found in medical hospitals, and there's slight differences between the two of them. Now, a positive pressure system, we'll talk about that one first. It is a protective environment, is what it's considered. It creates high pressure within the room by forcing the air out of it. So it pushes lots of air in the room, and air from the outside cannot enter in because the pressure is higher. Now, you have to have certain conditions in place for this to happen, some of which are to seal the windows, seal the doors. Everything has to be sealed in both of these systems in order for them to actually build pressure or not build pressure, which we'll talk about here in a second. But the positive pressure, as an example, would be a cancer treatment room. So the goal is to keep vulnerable patients safe from other infections or diseases. And this is done by pushing all the air outside. So when a door opens, people enter the room, air does not come in with them. Everything gets pushed out. We're keeping everything we can out of this room for, say, an immunocompromised person. Now, the exact opposite side of that is the negative pressure system. The negative pressure system creates low pressure in the room. So it's the exact opposite from what we were doing. Instead of pushing air out of the room, we're keeping air inside. That means we don't want anything leaving the room. So this is trapping harmful particles within a room. This can be seen in an airborne infection isolation room. And an example of that would be if someone had Ebola, they don't want it to spread. They'll probably be wearing, hazmat suits. And so this is a good solution to keep people outside of the room protected. Now, something important to note about this is there are a lot of things that go into making a positive and negative pressure system, and they're usually in existing facilities. To implement this into a new facility can be very costly, and it is a good solution. However, like I said, can be costly because you have to seal the doors, to seal the windows, all of the above. Now, there are a few other methods on the market I'll go over very quickly before we get to the last one. And these are heavy sprays, fogging and fumigating, electrostatic spraying. All of these are not really recommended. They are being used currently. However, the CDC has not proven that any of these are effective, and most of these are all surface disinfectants. They're not controlling the air and the quality of the air. So heavy sprays, they can cause breathing issues. Fogging and fumigating is really used for pesticides and bug problems, not necessarily for COVID and indoor air quality. Electrostatic spraying is similar to the negative ions. There is a way to use this. However, like I said, it doesn't actually clean the air. It's only cleaning the surfaces. So that brings us to our last section of indoor air quality ventilation devices and strategies for improving your indoor air quality. And that's ultraviolet light. We talked about this a little bit already in the HVAC systems. However, there's two more sections that are really important to note. First of which, we'll go with the UVC lights in portable units. These lights can be installed into an everyday room. You might even see these in a hospital setting where they turn lights on at the end of the day when no one is going inside that room any longer. They are actually openly emitting UVC into that room to try and kill any pathogens, viruses, bacteria on surfaces. Now, obviously, if you're openly emitting radiation, no one can be present in the room at that time. So this is one issue that we do see, and it does actually have has a problem cleaning surfaces that are covered. So this is called the shadowing effect. So if I shine a light at my hand, everything on my hand is clean, and behind on the other side, where the light is reaching, is clean. However, right behind my hand, there is no light hitting the surface, so it's not being cleaned. That's one thing to consider with these devices. The portable units are the same. You push them into a room, it emits UVC light, and it turns off at a certain point, and then you roll it out. this still is not cleaning the air, and that's one of the most important things we need to consider. And so the next thing that we're going to talk about, which is the upper room UVGI device, does clean the air, and this is CDC recommended. So what this does is it's actually a unit that goes into the top of your room, usually gets tied in with a lighting system. And what happens, excuse me, what happens is the air gets pulled in and it goes through a series of UVC lights. Now, this is actually at that same wavelength that the HVAC is at, so the 265 to 275 nanometers, which is optimal for killing germs. And then it's also close enough that the germs are being effectively irradiated. This is called the dosage. So that combined with the time of slowing down the pathogens, the air that flows through it, giving it enough time to be exposed to that light, actually is effective in killing and inactivating pathogens. So it actually breaks up the proteins and they're no longer active. Now, these devices have been used since the mid-1990s for killing and inactivating tuberculosis in a hospital setting. And in fact, this device and some of these devices similar to it are used in testing some of these other methods that we were just recently speaking about. So there's no UV leak from the system. You actually can be present in the room while these are working, meaning that the air is continuously being cleaned while people are using it. And it focuses solely on cleaning the air. Everyone can clean the surfaces, Clorox wipes, so on and so forth, routine cleaning that's unnecessary. But our goal is really for the indoor air quality. So we need a solution like this to clean the air. And the nice thing about these two is that there's little maintenance involved. So we'll talk about some available funding for improved ventilation for coronavirus protection. Actually, the government has released a few things in different industries, education and healthcare being some of those. There's the emergency assistance for public schools that's in the form of ESSER funds. There's 1, 2, and 3. 3 is actually just now being released to the schools. And then there's a EANS funding for non-public schools. Healthcare is also a section that got some funding, which is the H8F fund. And you can actually click this link and see that for if you're a healthcare or if you're interested in looking at that. And then finally, the American Rescue Plan Act was just recently released, and this is for the entire country. And so is the education and healthcare. However, this is the newest one. Every county is getting allocated funds specifically for Lee County, where Energy Harness is located and headquartered. They're receiving $149 million in funding, and that is specifically to be used for preventative measures against COVID, one of which should be your ventilation and is detailed in the plan. This includes the UVGI devices that we just recently spoke of, that is approved by the CDC. And so if you're interested in looking at that, I highly recommend that you do. This could be used for any businesses in the area here, and it's probably the same if you're in a different part of the state, part of the country. There's different allocations for funding that you can take a look at. So why improve indoor air quality now? There's really quite a few reasons to do this. Health and safety being the utmost importance for our individuals, our employees, our customers. We really can't afford to lose any employees as we move into 2022. We've already had enough people being sick, being out for multiple weeks, if not more, which really puts a strain and a stress on everyone else in the business, as well as the company itself. The funding is available now to implement these preventative measures. So we need to be proactive and take advantage of what is existing. So that way we can protect ourselves now and in the future. And then we need to address the problem with indoor air quality. It hasn't really been addressed in the past few years. And we see that it continues to be a problem and we are suffering from it. So it's good to be proactive. Lastly, we want to maintain a good public perception and protect ourselves against coronavirus, future viruses, and pathogens. Coronavirus, as it has unfolded, has really been the main concern. However, there's the flu, there's the common cold, there's many other pathogens, and there's many other mutations that are going to be coming along consistently for forever. So we need to address that. We need to realize that as a concern. These are the references I spoke of earlier. These can be these bring you to the EPA's website, OSHA's website, the CDC for ventilation, as well as Florida Health. And then finally, if you have any questions, please feel free to reach out to me. This is my information below. This is our headquarters here, where we do make and distribute the UVC disinfection lighting, those upper room germicidal devices that I spoke of. I feel happy to answer any questions. If you're just curious about UVC, if you have anything else that you'd like me to speak upon, please feel free to reach out. Thank you for listening today, and I hope this was an informative message for you guys.